tell you a little bit about us. You might not know us, but we've been around for 14 years. As you said, over 2,000 people in the network. We have a revenue of 120 million last year. We're international, you know, as well as our London offices, in both London and Manchester offices in the UK. We also have people in Europe, in Portugal, in Berlin, in South Africa, in India, Australia, and the States. So we're, quite a wide organisation. And really, we were put together with a view to create a space in which developers and technologists can work together with their clients to solve their problems. And that's really the ethos of us, and that's how we like to work. Could you launch? We have a poll during this talk, which I think will be put up. I'd be really interested to get everyone's view on, kind of what their challenges are with machine learning. And so if you can find some time to fill that in, that'd be brilliant, and we can look at it at the end of the session. Thank you. Okay. We are we work with lots of people from lots of different sectors, both in private and in government. Here are some of the names we work with, lots of others that you know about, and these are ones that have, we've worked with on a data area as well. A lot of our stuff is very focused on data.
Just super quickly going to jump in, Simon.
Yeah.
Are you flicking through the slides? Were you showing some logos there?
I was, yeah. What's happened?
It is not changing on our end, I'm afraid. So I'm still just seeing it saying productionizing data science.
Okay.
Can you that seems to be moving through. Yeah, what we do in data.
Hold on a minute. I'm not sure what happened there. Hang on. So just saying, here we go. There's some logos there. Thank you, David.
No worries. Have a good one.
Thank you. Some of the people we worked with. And now I'm going to, what we do in data, so we do a lot in data in EE. I lead the data aspects of it. And really there's kind of three main things I think we do that clients ask us to do. One is data engineering. So it's that creating the data pipelines, creating the data warehouses, getting the data into a good shape so that the people who need it, the data scientists, the BI people can do great things with it. Some of our work is around, algorithmics. So that's, creating the automation of the algorithms to do stuff, whether that's forward risking or things like that. And we'll talk a little bit about some of those in a minute. And of course, it's the stuff that sits around those algorithms, the ML ops, if you like, about, how do you host those algorithms? How do you make sure that the data is fed to them in production, all that sort of thing. So we'll be touching on those today, I hope. You can find out more about us. As David said, we do some content, and we share lots of our thinking and stuff with people we like and other kind of technologists. If you go to our website, you can find lots of stuff there. There's lots of great stuff in our blogs. Really good one about unit testing for DBT, if you're interested in that. Also, Paul, who's going to be talking a little bit later, great blog on some tips for handling data in data warehouses there. But there's lots more. Go ahead and have a look at it. We do online talks as well. So there's some interesting ones there. And I've just picked one out here about some of the work we've done at HMRC. And kind of bigger content, we have some playbooks in the data space. There's a data pipeline playbook, which we released last year, which has been really good and really helpful. And we are currently working on an operationalizing machine learning playbook. Hopefully we'll be out within the next couple of months. So keep your eye out for that. Right, I'm going to talk now about a piece of work to create a tool for estimating the prices of used vehicles for one of our clients. It's a great piece of work, I think, and a great example of the sorts of things that we do in the data world. The work included data engineering, algorithm development, ML ops, so I thought it was a really great one to share with you today. I'm going to talk in a short space of time, hopefully. I'm going to talk about what the objective was, how we arranged ourselves, and how we arranged ourselves to kind of meet those challenges, the data, what we worked on, and how we kind of worked with that data to get to the point we needed to, and a sort of description of the architecture we used. So I hope it will give you some ideas about how we like to tackle these sorts of problems, how we like to organize ourselves, and the architectures we use to manage data and machine learning. Okay, so I'm going to start with the challenge first. So we are asked to create a tool which is able to estimate the price of a used vehicle. You can all imagine the kind of thing. What's the estimated price for a 5-year-old Ford Fiesta with 60,000 miles on the clock in the UK, for example? And largely, it was a blank sheet for us in terms of what was in place, so we could start from the beginning to work out what the tool should be, the best way to kind of deploy it. And obviously a critical part of that work was working with the data, so exploring the data, understanding the data, and creating those pricing algorithms, as well as developing the pipelines for processing the data in production. Another really important part was the UX, user experience. So the users are not data scientists, they're ordinary people. So we spent a lot of time working out what visualizations would work for them, how to show those estimates in a way that would give them confidence in the results. And also, I think because we are big believers in continuous development and things like CI/CD, all of our work really follows and works within that kind of framework. It was important that we could create that environment for our client, and so the system can be continuously amended and updated without any drama. So how do we do this? We like to work in cross-functional teams. Equal Experts, it's a network of experienced developers and specialists, and typically our people have over 10 years of experience, so we like to work in pretty flat teams, really. We had a data scientist here working closely with the data engineer to create those data pipelines, and obviously the algorithmic prototyping was done by the data scientist. We had UX designer and some developers working with those users to work out what's the right way to present the data and the estimates, and a platform engineer to do all the kind of the CI/CD and the terraforming and all those good things. As a team, we work to the kind of these principles. I've already spoken about continuous delivery, and I think I've described the one team approach we had to you. But we try to be lean in our architectural choices, and we generally don't design everything up front. So we want to leave space to pivot the design where we think it's right. So we follow that principle. And again, because we want a tool that is easy for our users, understanding our needs and providing an interface that works for them rather than just our data scientists is critical. So being user-centered is important to us. The process is really a fairly typical process. We started with an initial proof of concept to understand the data, do some prototyping of the algorithms, and initial visualization in Power BI to get some visualizations. It became clear that Power BI wasn't going to be enough to meet the user's need. It wasn't going to be enough to make it easy for them to understand what's going on. So we pivoted to React, and in the production system where we we built a UI in React there, as well as obviously creating those production data pipelines and standing up the machinery to manage the machine learning infrastructure and the monitoring. We're now in the third phase, well, in the sense that it's in operation. It's been in operation now for over a year, and we're monitoring refining those pipelines. There's a much smaller team there that is effectively doing amendments and new kind of features on the platform, and it's very successful. It's being used across quite a wide range of users. Little word about the data. So the data, effectively, you're amalgamating data from a variety of sources to understand what a kind of a good price should be. The data itself is arriving at a weekly cadence. It's not a huge amount, it's about 10,000 rows a week. So we architected for that. We didn't need to architect for massive amounts of data. And there was significant overlap between the sources. And obviously that's one of the big challenges, is being able to merge these data sources, identify when there are duplicates across different data streams, identifying when there's missing data, and then kind of filling in that data where possible. Where you have kind of matching duplicates across different data streams, deciding which is the higher quality data source. Some master data challenges, making sure that we had an agreed view as to what the geographic regions were and the product hierarchy was. And then some other little bits and pieces that happened in the pipeline, things like inflation adjustment on the pricing and things like that. A big part, I think, of a piece of work like this from a data point of view is the acceptance of the model. So acceptance isn't just having the lowest error. And in fact, in something like this, error is not a very helpful statistic. We found a much better metric to work for really is kind of acceptance from the dealers, and that was what we went for in the end. The architecture, So the tool is implemented in AWS, and the key parts of the architecture are either Lambdas or microservices, which we hosted in Fargate, again, trying to be lean. Fargate was sufficient to meet our needs easily. What happens is the data lands in a bucket in S3 at the top there, which triggers our data pipeline. So there's a container that manages the data pipeline. It's a relatively simple pipeline, so it's implemented in Python with modules for each Python stage and a simple piece of Python orchestration. Originally, we were using a cool tool called DVC to create the models, but we found it much more complex than we needed, and it added to the disk and memory usage in a way that we didn't need, so we kind of pivoted to a much more simple orchestration approach. The algorithm training so that's the data pipeline. The algorithm training itself is hosted in a separate container, which gets triggered at the end of the pipeline run. The output of that training is a binary, which is saved to an S3 bucket, and there's a service, an estimator API, which is prompted to update its version of the model when a new version goes into that bucket. Another little point there at the bottom is the Snowflake. So during the work, our client adopted Snowflake as a corporate data warehouse. So we added an extra stage on the end of the pipeline to take the new data and add it into a table in Snowflake for wider use across the business. So that tells you effectively the data pipelining and the model creation, the MLOps side, if you like. Then the mod itself gets used within a wider web application, effectively a React application. So there's an endpoint, there's an estimator API, which is also hosted in Fargate. The model actually can get hit quite frequently in a short space of time. So we have an Amazon load balancer in front of it so it can scale up to meet the demand that's needed. And we haven't yet found a situation when that hasn't been enough to manage the load. So hopefully that's given you a good idea of a kind of a project that we've done that kind of covers a lot of what we do in data and how we like to approach these projects. I'm going to hand over now to Paul.
Hello, thank you, Simon. Hi there, so my name is Paul Brabban. I'm a consultant with EE, of course. And my recent engagement is with an online retailer who brought me in to help improve their search systems that they through which you can search their product catalog and find things to buy. So if you've not worked in search before, I've had the privilege of working a couple of times before with search problems. And if you've not worked with search before, you can, a lot of the complexity that's going on when you start typing things into the box can kind of really pass you by. I mean, it did for me before I really kind of started looking into it. But these complex systems, essentially they are trying to solve like a fairly simple problem. I think I've managed to distill it here. As somebody who would own a search system for an e-commerce outlet, I want people to be able to find stuff they're looking for, because if they can't find it, they can't buy it from me. They'll probably go and buy it from somebody else, and I'll not make some money I could have made. So it sounds simple, but there's a lot to it. Now I'm just going to focus on one little element of this just to give you a flavor, if you've not come across it before. But if you think about what your no results found page, so your customers type something in and you don't have anything, your search engine can't find any products that they might be interested in. What do you do? If you go and Google, I mean, it's a bit meta, Googling for what to do when your search engine can't find results. If you go Google for no results found page, you'll find loads of advice as to what to do. But some of the things you can do, so if no results found, I typed in ruby slippers and we get no results found, maybe because it's all one word and I need to split them up to recognize them. What I could do is suggest some categories that you might be interested in instead, rather than just presenting a dead end. I could suggest some categories. I could maybe offer some alternative search terms that might be useful for you. So did you mean style things, or customers also searched kind of idea. Just what I want to try and do is continue that conversation, not just kind of end it here. Other things that you might be able to do is present some recommendations, particularly if you can identify who that customer actually is and you know something about them, then you might be able to make some useful recommendations. You can always serve ads or sponsored products as well, and so on. There's lots of things that you could do, and you'll have seen them as you've been using search engines online before. Now, some of these things can be tackled with like human intervention, so rules, systems, that kind of things. If you think about the category suggestions, we could have a system in which people could kind of record terms or words that appeared in terms and then suggestions for categories. So the fact that slippers appears here, we could have got a rule that says, oh, slippers suggest footwear or something like that. But as you can already probably imagine, that doesn't really scale very well. I mean, it's not unusual for kind of a popular sort of retailer's search system to be kind of heading upwards of like hundreds of thousands of individual unique search terms every week. You know, the humans can only do so much. So finding ways to use data to drive these products, to kind of harvest data like the customer behavioral data, that how they're using your product, the kind of things that they're interacting with, kind of products they're interacting with, what they're buying, along with information from your product catalog and all sorts of other sources, finding ways to bring this data together and use it to drive the way that these systems behave when you interact with them. Yeah, it can be super valuable. So that takes me on into this engagement specifically. Next slide, please, Simon. So I landed in the team as this particular client was really building up like a more powerful search engine solution. I landed in a really capable team that was made up of the consultants and the client's own staff. And they'd already recognized the value. I mean, they already knew all about the value that was possible if they could get hold of data. And to that effect, there was a data scientist in this team. At the point at which I landed, the data scientists were doing great work. Were really kind of like very sort of competent, innovative sort of ways of looking at the data that was available. But they were the only one who could do that, and they had to log into complicated systems with lots of specialized tooling to be able to go and perform analyses, and then more importantly, extract data from those analyses that could then be used to mold the behavior of the search system as customers are using it. So you can see the issues with that. This having to have like a very expensive, effectively, human being, the data scientist, go and pull data out of your data, your warehouses to be able to tune your system. It's something that can't really be done on the fly. In fact, even just doing it daily is not really feasible. Doing it anything more than on an ad hoc basis when someone asks becomes quite challenging. Because it's a manual process, you know, there's a good chance that you're going to have issues with repeatability. The data scientists know what they're doing, and perhaps if they're all sick and you need this work done, maybe they missed a step when they wrote down the instructions as to how to do this, and now there's a problem for somebody else trying to follow their process. The last sort of detail here is the fact that, and I think Simon's already mentioned it, and I think Scott mentioned it as well. The data scientist uses Python, and pretty weird Python at that. You know, Python and pandas and NumPy and all this sort of thing. No, normal software engineers don't use those sorts of tools, and in my experience, they don't even use Python at all. Every time I've interacted with data science teams in a professional role, it's been Python. Software engineers who have kind of the practice and technique skills to be able to perhaps support the data scientist, they don't use Python. In my experience, I've worked with teams using Java, Clojure, Kotlin, Node.js, pretty much anything, but I've never come across Python. And again, that's my personal experience. It certainly does exist out there, but there's a siloing effect. A wall is up effectively before we even start because of this, the different languages that the two sides of the team are using. It becomes two silos. The goal that I had landing here was to kind of make it possible for the data scientist and anyone else with data questions, make it possible for them to perform their analyses, answer those questions, and build a data-driven product without having to rely on a data specialist, a data engineering specialist like me, being able to kind of self-serve and fulfill the wider needs of the team, which are the team is empowered, the team is agile, moves quickly, needs to be able to move its own pace. It can't be sitting in queues all the time. So that was the goal. That's kind of how this connects back to productionizing data science, trying to make those capabilities available, effectively make myself redundant. So how do I approach that? So next slide, please, Simon. The team was using architectural decision records, which you've probably come across. It's just a pro forma, helps you make a disciplined decision and record that decision for future reference. So I can go back and look at what we were doing at the time. So I just put out a couple of details from that for you. I was looking at these sort of what capabilities these systems would have to be able to move data around and perform the kind of processing that we needed to do. looking for the simplest systems that we could get away with, systems that were effective, cost effective, good integrations into the services that would need to consume data from them, and familiarity for the software engineers in the team in particular. Airflow is the obvious choice. If you're doing data engineering, I need to build data pipelines, I will use Airflow. Now, I've not used Airflow in Anger myself. I have been in teams where it has been used, but I've not used it myself. I gave it a good solid look as part of this piece of work, along with a teammate who was a software engineer. And we didn't much like Airflow straight off the bat. We looked at it for maybe a day or two, kicked the tires locally and stuff like that. We found it had quite a weird API. The fact that it wasn't container native by design didn't feel very modern either. And it did not seem to be a good fit with the way the rest of the team works. So for context, the team was working in Kubernetes, in cloud environments. So they were very much containers and cloud services and stuff. And that's not native to Airflow. I know it can be bolted on, but it kind of felt like a bad fit. And also it's quite an esoteric kind of programming model compared to other things. So we put Airflow kind of on the back burner, looked at some other options. Kubeflow was the next thing we looked at. It's a much more modern option. This is a year or two ago, so things may have changed. I don't think they have really. Much more modern option. It's container-based natively. So it kind of felt like a much better fit with the way the team was already working, but it still had a Python-centric lean. It was very machine learning-centric, and some of the things we need to do were just about move this data to there, run this query, put the results there. There was no machine learning element to it. So there were questions about whether it would be difficult to do those simpler workflows and whether the complexity was necessary. As we were looking into that, though, we discovered that Argo workflows actually underpins Kubeflow. I think it did at the time. I think it still does. So we went and looked at Argo, and it seemed like a good fit, like a good bit of a Goldilocks kind of solution. Language agnostic, didn't force Python. It was container native. It would work well in the cloud. Configuration via YAML, very much in the Kubernetes style. So we thought this would work well in the team. Next slide, please. So this is what we implemented. This is basically the workflow for getting these pipelines up and running and out and doing useful work. You would write the code. It would typically be like Python code, shell scripts, that kind of thing. Push that to GitLab, the CI/CD system. GitLab would then push images to container registry. The DAG, so DAGs, if you know across the term, directed acyclic graph, is basically a pipeline definition from this perspective. So the definition separate to the actual the images, the logic that runs in each of the steps in that pipeline. That's what goes to container registry. The workflow DAGs would get pushed across. Sorry, is that better? Hopefully that's better. The workflow DAGs would get pushed across to Argo, which would then pull images from the container registry as they were needed by the workflow. It would interact with our data sources and cloud services like CloudML and generate some value. And this is how we were working for about, thank you, I'm glad. This is how we were working for about a year. So at the 1 year point, we had a bit of a retrospective specifically on this topic. And there were some positives and some negatives. The big positive was that we really unlocked data-driven work. The team was now able to build and run data-driven products, able to iterate as fast as we could come up with new ideas, as fast as we could run A/B tests and analyze the results. So we really kind of unlocked the value in data, and we delivered solutions that had demonstrable impacts, like demonstrable positive impacts on revenue and interactions customers were having. But I completely failed to meet the goal of essentially making myself redundant. I was the data engineer in that team. I looked after this infrastructure. I did most of the work. The big problem that we typically had was just that it doesn't quite work the same way as a normal microservice-based cloud Kubernetes project. It's a different way of approaching things, and unless you're working with it all the time, you basically have to relearn how to write DAGs, how to think about DAGs, and run these kinds of workflows. And that was a real challenge when a willing volunteer from the software engineering side would try and write a workflow. We'd work and we'd build just enough skills to get it done, and then they wouldn't touch this whole side of the world again for another 6 weeks, 8 weeks. And by the time they came back to do the next workflow or make a change, they forgot how it all worked. So yeah, a pro and a con. So we started reviewing what we were doing and back to the KDR process and looked at our options now with everything we'd learned. And a teammate from a peer team that we were working with asked the question, why don't you just use GitLab? Next slide, please. So we started looking at that option, and actually, I feel terrible. I didn't really think about it. I didn't really seriously consider GitLab as an option for actually doing the work, as opposed to just building containers and doing version control and doing deployments. So as it turned out, we'd actually inadvertently built a couple of workflows on GitLab kind of by accident, alongside the Argo workflows without realizing it. So we decided to give it a go. Could we move our workflows from Argo to GitLab? Would that work? Now, I'm just going to give you a quick rundown of why we thought GitLab might work. So what features are missing in GitLab that we need to run data engineering workflows? I mean, it has DAGs. I mean, there's been a change in the last year or so that makes that a lot easier to use. You no longer need to define layers of stages. You can just say this depends on that. That's nice. You can define schedules and run things on a schedule. You can run builds on triggers. It supports artifacts and passing artifacts between stages. It's very scalable. It's got lots of operability stuff built in. It's container native. It's language agnostic. It has RBAC and lots of other security things that we would expect. And the two really key things, all that stuff enables us to do sort of basic data pipelines. But the two key things are familiarity. The rest of the team is using this all the time. Even if they don't touch a data pipeline for 6 weeks, they're still using the system all the time. And alongside that, it's somebody else's problem to run this thing, and it's already being run for us. I don't have to bring in some tooling and then find a way to make it effective to run that tooling for. It kind of implies you have to a certain amount of scale before it's even worth looking at. Whereas the GitLab already being there, we kind of live off the land. If this can do the job, then it's going to make things a lot more sustainable. And yeah, net results. So now we are probably 6 months on from that decision point. All of our workflows have moved off Argo. We've decommissioned the Argo cluster and the underlying infrastructure, and everything is fine. Everything is working the same way as it was with Argo, except that now there's typically a lot less code in a workflow, because one of our workflows I was looking at the other day, it's less code now in GitLab than there was there before, and it's actually running the workflow for us. So it's surprising the degree of simplicity that this change has brought, and so far it is working very well. I don't want to say we've solved the problem, but so far the indications are good. Next slide, please. So yeah, I just want to kind of summarize with, I mean, it's okay for me to talk about one specific anecdotal experience, but as part of doing this talk, I want to have a think about what can I pull out of this that might be more generally useful. So I wanted to draw attention to a few of the reasons why I think this worked for us. On the left-hand side of this diagram, we've got like CI/CD solutions like GitLab are getting better and better and more capable, and it really feels to me like they are kind of overlapping more and more with the kind of capabilities that your data engineering tooling provides. So I think there's a bit of those capabilities are improving. On the other side of the diagram, modern data warehouses, like they're really hyperscale, like data processing clusters more than they are databases these days. These modern data warehouses, they have abilities that are pushing them kind of left in the pipeline. They can ingest much more different varieties of data and handle issues in data a lot better. And one of the big enablers for us is the support for ELT pipelines. So instead of using something like Airflow and just moving data down stages in the pipeline, we can land the data and then use views and database to do the transformations on the fly that are needed for our analyses. And actually, we've been making heavy use of that, which has enabled GitLab to do a lot less work, or whatever orchestration tool we were using. We also use CloudML skills, not on the diagram here, but on an earlier slide, CloudML was mentioned. So where we have done a couple of things with machine learning, we are actively trying to move that capability into a dedicated solution that handles all of those. I mean, Simon just talked about it in depth. There's lots of very specific machine learning things, evaluation and human in the loop stuff and so forth. We think we are using specialized tooling to handle that specific kind of complexity. And the skills availability. So the people blob is the third one. I actually think that the people challenges here are the challenges I've hit before, and I've not really found a good way of solving. And I'm quite excited that this might be a good way forward. And it really is just kind of meeting people where they are and living off the land. It's what can I use that's here, rather than bringing in new stuff that's weird data engineering stuff. So yeah, a prediction for the future, you know, I'm inevitably going to be wrong, but I think we might see data engineering pipeline specific solutions start to just get squeezed a little bit, start to find other ways of solving those problems that don't involve so much specialism, which would be great because data engineers are hard to find in the market right now. A couple of the little details just to wrap up. So if you're considering doing looking at something similar, so this is lining up with a sort of a data mesh style approach. I'm just solving a problem for my team rather than trying to build some platform solution for the whole organization. I wouldn't want to comment on the suitability of the approach I'm taking for that sort of big platform solution. I haven't really thought about it. And alongside GitLab, so Terraform plays an important role, and we are still using tools like dbt, which has, again, Simon mentioned, to help enable good data engineering practices, particularly in that case, when it comes to ELT pipelines, give us the ability to kind of treat them like infrastructure as code. So we are still using some data engineering tools. We're really trying to narrow that down and make sure that it's delivering lots and lots of value where we are using those. And that is the end of my deck. I hope that's been interesting. Thank you.
Cheers, thanks, Paul. Hi, I'm Scott Cutts. I'm a consultant of equal experts, of course, working with data for several years. And I'm going to talk about a client we worked with and a project we worked on where we've been going through like a journey of evolving from like a kind of software engineering application kind of based approach towards a data platform. And I'll talk about how kind of data science has scaled alongside that on the way and how it's influenced our approach. Next, please. Yeah, so we really had, I guess, initially the problem was seen as a software problem. You know, we landed, it was like software engineers were kind of the core of the team. And this was all about kind of fraud and risking as a problem area. That was what we're looking at, the domain in general. And this really grew over time, right? So we had quite a massive, like in the end, we've got quite a massive data set, but at the start it was quite small, and it really grew and changed as we went on. And we went from like tens of users consuming this data to thousands currently. And data science really kind of helped kind of evolve into that kind of shift from software to data. And it kind of, I just want to talk about how we scale that out in that approach. Next. So this was it was like quite a small problem at the start. So we basically had a bunch of fraud investigators who we wanted to serve data up to. We were collecting interaction data across an application platform, which had several services, and they were sending us like JSON data and event stream, which we were collecting into like a unstructured data store. That data store was the main interaction that the investigators would have with the data, like direct access. And we would consume that data into like our application that we would transform it using software. So this was like JVM and Scala, like regular software engineering. Transform that data into like a summarized form, push that out to RDS, to a data store, and serve that up to the case investigators with like a case workflow on top. So this is very much an application at this point in time, and yeah, quite small. Next, please. So of course we have data. We're looking at fraud, and there's an obvious case there. Can data science really help us identify fraud? Can we apply machine learning, and can it help us solve the domain problem? So we kind of did that by landing a data scientist into the team. So we're kind of starting to build that cross-functional team that Simon and Paul have both touched on, and they were embedded in there with the software engineers. And we basically just kind of took a replica of the RDS database. We put a simple data analysis environment on top with like, executable notebooks, and software engineer and the data scientist kind of built out like a very simple kind of batch prediction pipeline for ML on top of that, which would push to Kafka, and that was ingested into the fraud app and would surface in it was like a very kind of general model at first, surfacing scores about how fraudy something looked, which they could use to help drive their investigation. Kind of like some of the things that we saw from this that we didn't quite expect were that, like, a data scientist, they really know the domain well, the data well, and they really help the software engineers start to kind of bring data thinking to the data transformation they were doing inside this application. And it really started to change kind of how the team were viewing themselves, right, and where we were headed. We did really prove out that analytics in general had really high value for the team. So it wasn't just the kind of, I guess, the ML problem that we were trying to solve initially. It was just the general analytics data scientists were bringing in, the way that they talked to the investigators and the users, and they could really show like deep insights into the data that they weren't previously getting. So we're starting to head into that data-driven form as a team in general. Next, please. So kind of alongside this, the application platform that's feeding us this data is having massive growth, and it's grown up to like 800 plus services. So we're starting to get much more data than we can kind of handle with this very simple, kind of software processing JVM approach to it. And the machine learning is also struggling. Like, it's a very, very simple Python-based pipeline. It's all being done in memory. There's no distributed computing as such. So we're really starting to suffer with the scale of the whole thing. Another thing that we started to see was the data is being used outside of kind of the fraud remit. Like, it's very useful to the organization as a whole. We're seeing kind of performance analysts using it. We're seeing it being used for kind of all kinds of BI tooling. We're seeing the service teams also finding usage, for themselves. So we realized we need to start to, become a data team, I guess. And so in order to do that, I guess I think because it was there to an extent, because we already brought Kafka on, and because we were kind of a still software focused team to an extent, we tried to use Kafka to start to do kind of heavy lifting data processing. And this is like the Kappa approach, which I'm sure people heard of. And it didn't really work out for us. We had too much data. Basically, we kept hitting kind of memory constraints with RocksDB and Kafka, and getting out of memory errors. And doing, like, at the time with Kafka, this was several years ago, Kafka still hadn't really evolved into the batch processing tools that it has today. It couldn't handle complex transformations very well. And I guess the real core of it all was we were trying to do batch processing, right? We didn't need to be real time. We were kind of using the tool for the wrong purposes. So we kind of shifted into data engineering. So next slide. So we realized we needed this data approach. And I guess one of the first things we did that really empowered it was kind of forking that event data out. So we started to store our data in S3 data lake as well as this unstructured store. And that meant we could bring in tools like Spark and EMR to start doing heavy duty processing on top of that data lake. So to do that, we started to bring in some data specialists, like a data engineer, who could work on that. And this is kind of, I guess you can see here, it's really lowered the scope of that application. So that the fraud case working app, we've kind of removed that kind of domain out into its own pipeline, which was a nice accident that we had a very focused data domain pipeline in that initial phase. And the data engineering and software engineers kind of worked together on that. They proved that we could start to do kind of this big data processing, and it became like a data product in its own right, this summarized customer interaction data. And that had the carry-on effect of enabling the data science to really grow and start to scale. So now we had EMR, we could point our notebook processing environment in EMR, we could use the summarized data product, and we could start to build our own kind of behavioral analytics insights pipelines to really drive off that, and we could expand our machine learning out to, we've got much wider range of history, much better accuracy, and just more power there, really. Next slide. So I guess one thing that's worth talking about is kind of that cross-functional team aspect with the data scientists and engineers. So kind of I guess it's a typical production phase. We would have, like, the data scientists would do their analytics in the dashboard. They would test different machine learning models out, and then they would come and pair with software engineer, and we would kind of really do test-driven development on that pipeline and apply engineering best practice to that pipeline. And a cool thing that kind of happened was we tried out behavior-driven development, and it was nice to kind of see we had like a data product owner and a data scientist and engineer all sitting down together and writing like a BDD spec together, which was a really nice way to share like how a model works and communicate that out amongst the team. And move some of the data science knowledge out to everyone else. We added like a simple metrics and monitoring platform for our machine learning models, so we could see how they're performing over time and make sure they were being consistent with the scores they were returning. And this was because we did kind of have some regressions. There was some AutoML libraries involved, and we did see just because of some bugs in the libraries, really, we saw those models crash out, and that kind of helped us be aware of those problems and be consistent. And now we kind of had that. We had the ability to start to have several ML models, and the kind of initial generic forward model we had at the start, we could start to segment that and look at different approaches. We were shadowing models in production as well, which gave us that kind of experimental view, kind of that similar to A/B testing, so you could see which, how models were performing against each other. And I guess the biggest benefit, more than the ML to an extent, was we started to actually create analytical data products. So we were surfacing longitude, like historical behavioral insights to the fraud caseworkers, which really allowed them to get like a long, several years view over what they're investigating, and that's really helped them do their jobs and get a bit more action across the data that they're looking at. Next, please. Yeah, so we're still growing, and we're seeing more and more people who want our data, basically. And we've kind of linked into the domain-bound pipeline aspect that we're seeing. And so we're kind of like, as new use cases come to us, new requirements for data, we're kind of seeing it in a domain point of view, very much like microservices, because we're kind of an offshoot of this application platform. We're already working in a digital application platform concept. So it made sense for us to domain scope our pipelines that we were processing, and it also let us domain scope the analytics. So like we dealt with the problem of kind of data authenticity, like how can we trust the data that we're getting, and that was kind of seen as a different domain problem to fraud, and it allowed us to basically have different pipelines, different machine learning pipelines that could do both. We also leverage Spark, and this is something that Paul touched on, that flexibility. So we could use, engineers could use Scala, data scientists could use Python, and we kind of use Spark and the Spark API as the kind of meeting point where they could both work. And yeah, Scala was used for kind of the big heavy lift, like summarized data products, like that customer interaction product we talked about, whereas you would use Python for your analytics and machine learning. Because we started to have kind of many data products now, because we're scaling, we kind of set up a standard for that. In our case, that was having all our data sets going into S3 and Parquet using Apache Hudi. Apache Hudi gives you kind of ACID guarantees across S3, so you can update the data while other people are reading from it. And this is for pipeline sharing and such. And we're starting to now kind of really build out common mechanisms for surfacing that data. So putting into analytical tools so users can access it, surfacing it up into APIs so we can share that data out to the rest of the organization, and they can see our analytical insights and machine learning as well. And as part of that, we've recently created a data platform team who's helped driving this. Next, please. Next, please, Simon. Thank you. So if this sounds familiar, it's some of you might be aware of the data mesh concept. And we kind of became aware of it about kind of halfway through that recent journey I talked about, because we were thinking of it in terms of like application platform and microservices and applying that to data. Finding data mesh was really kind of like finding someone who figured it out for us to an extent ahead of time. So that was great. And the idea of data mesh is that you have data product ownership, you have domain-based teams and cross-functional teams where applications and data engineering and data science all sit alongside each other. And this is kind of the journey that this is where we're at right now. And we're basically splitting out different teams kind of focused on different areas of our domain, like say like a bank account or like a credential. And within that team or domain, you would have, you've got your software engineers working for data engineers, and they're doing APIs, they're creating data sets, they're surfacing that data, and you have a data scientist embedded with those teams who are working on that focused problem just for that domain. And you've got the platform supporting that. So you've got your application platform and your data platform supporting that and smoothing that journey and making like a proven path of development for those teams. So this is, yeah, we're just doing this journey now, and it's looking promising so far. Next. So what were the kind of lessons that we learned from this? Cross-functional teams work really well. You really start to get different aspects being shared between the different specializations. Like data scientists are really good kind of technical BAs, and they really help out in that aspect. And software engineers bring that, you know, TDD and best practice to data engineering and data science. And data engineers know how to do, you know, the big heavy lifting, understand kind of distributed computation and those kind of problems. So it was really nice to have everyone sharing that within the team. Another thing, I guess, that kind of that domain focus view, like having kind of smaller data products and focused data problems and sharing those products out and having ownership of those products, really, you know, it gives you nice interfaces to interact with across the team, and it helps you then, you know, go into scaling. So you can start to have the product as the interface instead of worrying about kind of old school data engineering integration across the teams. And yeah, I think a data platform can really like emerge from a software platform. Like I think we saw that. And if you're already thinking in kind of digital platform or application platform terms, I think the like a data mesh style approach really fits quite naturally into that. It's quite intuitive to apply the same principles. Yeah, software engineers make good data engineers, which was, we kind of saw this triangle on the right happening quite a bit, where we'd have a software engineer join, they'll begin pairing with the data engineer, and then they would pick up enough to become a data engineer themselves. And the data engineers also picked up a lot of software engineering too. So you start to head towards more of, I guess, like a generalist engineering approach to this, which is really cool. And yeah, it's definitely worth getting data science embedded some way into your application teams. You never know how it could grow out and how it could scale and really help your organization grow into being a data-driven organization. And that's it. Thank you, everyone.
Perfect. Excuse me. Thank you all very much. Thank you all very much. Yeah, it was a really great session actually there, and I can tell by the Q&A that there's some good questions coming in as well. So maybe just invite Paul to flick your camera back on and come back. And I'll maybe get you to stop sharing your screen and we'll jump into the Q&A. So as has already started happening in the chat, we are already having quite a few people saying thank you. So this is our virtual round of applause. So if you have enjoyed today's session, please do give us a little thumbs up, a little emoji or a little thank you. It's really very much appreciated, and it lets our speakers know that there are people out there in the world listening to what they had to say. So just as they're coming through, actually, I will start to fire through a few of the thank yous and then we'll jump on to the questions from there, actually, if that's okay. So if you did ask a question in the chat, it does get lost a little bit. So if you can put a question into the Q&A, that definitely makes our life a little bit easier. And then the final one in the Q&A, there is upvotes. So I am a little bit conscious of time. We may not get through all the questions. So if there's a question in there that you like the look of, give it a little upvote and we'll make sure we get it answered for you. But just in terms of the chat, for the thank you for the team here, Pablo, Farshad, Alison, Imran, Alon, Maria, all saying thank you. Chris, thank you everyone. Tim Edwards, really interesting. I will be in touch. That is intriguing. I don't know what Tim's going to be in touch about, good or bad. We don't know. Jasper Wolf, Kayada, Emil, Nathan, great talks, folks. Thanks very much. Really insightful. Sam, thanks for the talks. Andrew, thank you very much. And the list goes on and on. Anna, Erin, Alberto, thumbs up, clapping emojis. I love to see a clapping emoji. That's the one I would definitely go for. So yeah, very well received for you three. So well done to the Equal Experts team. I'm maybe just going to kick off a question, and it was one thing that I was a little intrigued of, and maybe it's one for you, Paul. Lots of our clients use Airflow. Everyone I speak to seems to be a massive fan of Airflow, and I feel like I've maybe missed the memo there a little bit. So I was intrigued to know a little bit more about what sort of problems did you see with Airflow? Is there any more that you can tell us about that, please?
Sure. Yeah. As I say, we kind of kicked the tires for a couple of days, and I think just an odd programming model to kind of come to as a normal software developer. The way that the way that you pass variables around between stages, the way that backfilling works, stuff like that. Some of which is just not, as we've established, isn't actually necessary for the problem that we were solving.
Okay.
But I say I've got a bit of a data background, so I'm a bit biased. But the person I was reviewing it with was just a software engineer, and I think he summarized his view like really nicely. He said it felt a bit like going back to work on a J2E application server, having a dependency class paths and having to pack things up in special ways to suit the way that the application worked. So I don't know whether that was entirely fair or not, but it seemed pretty fair. I thought that was quite a nice sort of way of summarizing it. So just
Perfect.
weird, I think, basically.
It's nice. Well, it's definitely the way things are going with, you know, that crossover between that software engineer mindset into data engineering, and it is, as it happens with everything, it does all seem to be merging together. So it's always great to get that different take. I will jump into the Q&A. You guys will be able to follow along at the same time actually there. I'm actually going to go to Rob Harron's question first. Rob's question was on the second-hand car price model. What was the approach taken to missing data? Were values imputed, and if so, how was it done?
So the answer is yes, they were imputed. We did impute the missing values. Now you can ask me what imputation methods we used, and I can't remember off the top of my head. But I think it kind of depended on the field, effectively, what the approach was taken. But yeah, we imputed them. We didn't drop the rows. We felt we'd keep them for machine learning, effectively. Yes.
Perfect. I will stay with you actually as well, if you don't mind there, Simon. Next question there from Amy kind of leads on quite nicely. So Amy Holloway has the question. Hi, I have a question for Simon. Thank you, really interesting. How often is the model refreshed to ensure end users are using the most up-to-date data for their decision making?
So we get an ingest of data every week, a new ingest, and the model is updated basically every week, right, as part of that ingest. So it is refreshed. I think there's another question there about making sure, how do we make sure it's accurate? Is it Nadia did a question, I think, on how do you make, and so we have to, every week as well, we check the error statistics coming out of it. I got to say, there's another question I can't see here that somebody said, error is not the only thing, and it isn't the most important thing, in this particular instance. And in fact, actually, sneak preview of our operationalizing ML playbook, one of the sections is all about that, about how it's not just about the error, right? The error isn't the main statistic you need to look at, or even the most important one. And in this case, it was about acceptability, right? That they had to be able to understand how the model works. The people who used it had to see why a price was specified, which I think's related to another question about explainability. Yeah.
Perfect. Yeah. Thanks so much, man. You mentioned there, obviously, that a playbook. Can you tell us a bit more about that? What is that? You've caught my intrigue.
So I said at the beginning, we already have a playbook on data pipelines, which I recommend to anyone who's doing that business of, right, okay, how do you, I need to set up a data pipeline. And now we're doing one on operationalizing ML, because it's, the way our playbooks are built is if we have something where we've got a sort of sufficient experience and we think there's sufficient interest in it, we kind of get together and say, right, okay, what are the principles you need to take into account? What are the practices you use, and what are the pitfalls? And we kind of bring all those together within a playbook, and we share that. That's open sourced, right? So anybody can look at it and use that, and it's a way of getting that kind of practice, our views at least, across the community.
Brilliant. That's a great takeaway. I wasn't aware that you guys did that. So yeah, again, as mentioned at the start, very good for supporting the community. Well done, Equal Experts. I will fire back to the Q&A there. The top question is quite a general question, but it has had quite a few upvotes. So I'm going to throw it out there, and hopefully one of you can help out. Question at the top there from Jasper. Could you expand a bit more on behavior-driven development, please? Are any of you able to help with that?
Take that one. So behavior development is it's like the way to write kind of end-to-end tests embedded with your software that are in plain text English. And so you kind of write out the steps with the given, when, then kind of, it's called cucumber syntax, if you know that. And you basically can write this in English, and then there's a translation program that lets you interpret those into automated tests underneath, which you can then run against your code. And assert that those English statements make sense, and you can pass in parameters like, so in our case, we were passing in kind of like expected kind of, I guess, model score, but kind of bandwidths that we'd expect for the test to bring back.
Okay.
You could probably have a search of behavior and look at that, but it's a way of bringing together kind of BAs, product owners, and engineers, and self-documenting in the code as well being able to execute them as tests.
Perfect. Perfect. Thank you very much. Well answered, actually, because it's one of those, as you say, there's a bit to it, and sometimes getting a clear answer out of it is not always possible. So thank you very much for that. I am conscious of time. We do try to keep this 1 to 2 o'clock, but if it's okay, we'll maybe stay on for a couple more minutes. Is that all right for you guys? Perfect. We'll do our best to get through a few more then. So next question at the top there from Alon, specifically for you, Paul. Question around GitLab, and basically asking how you're using it. So he's asking is GitLab running the projects and holding all the data, and they pass data around to different modules, or is it running on pre-designed containers you've written? So can you tell us a bit more about sort of GitLab and how you were using it there?
Yeah, that's a great question. Thanks for asking it. So GitLab is orchestrating work that's being done elsewhere mostly. If there's any heavy lifting to do, then it will let the data warehouse do that. If it's complicated machine learning stuff, we pass it off to the cloud ML solution. And GitLab basically kind of like coordinates, do this, then do this, then do this. Smaller tasks. So I think a very small example of pretty much a real pipeline. We have a JSON lines file that gets dropped into a storage area every night. GitLab picks that up. Passes a JSON lines file into the data warehouse to ingest it, then runs a query in the data warehouse against that new data to run some quality metrics and push those out to another system. And that's an example of a pipeline. So it's doing, whether the processing is very small scale and does require something like Python, then that is being done in a GitLab task. But all the heavy lifting is being done by the data warehouse and the cloud ML solution.
Awesome. Thank you very much for that. I will quickly just jump back into the chat because there's 52 more messages come in. So it's always nice to get a bit of kudos, as is mentioned in the last message there. Great start to 2022. Kudos. Loads more emojis. Thank you. Great talks. Thank you all. Andrew Taylor, thumbs up. Thanks, guys. Really interesting. Thank you. Massive thanks to Simon, Paul, and Scott for a powerful session from Noor there. So thanks, Noor. Thanks, super useful. And there is still literally loads more that I could carry on going through from there. I'll jump back to the Q&A. Top question there is from Giuseppe. Can you elaborate what was the difficulty with DVC and what did you use instead?
Yeah, sure. So DVC, for those who don't know, it's a really nice tool. It's data versioning effectively. So you can capture what data was used to generate a particular version of the model. And we thought that'd be a really useful thing to have. It's got other things in it. You can manage a DAG in it. It's great. What we found for us is we didn't have a strong need to understand the data coming to version a model. We do need to version it, but we don't need to have that full kind of lineage. And it ended up using a lot of disk space on our container. And there are ways of using S3 containers and things like we weren't able to configure it in a way that worked for us. And because there wasn't a direct, very strong need for us, we switched to something simpler. I'm sure that there are lots of people who get great use out of it, but and there are definitely applications where you can see it's usable, but it wasn't relevant for us at that time.
Awesome. Thank you very much, Simon. Got a couple of questions there, I think, which I'll come to Scott, and then one just pretty broad general question just to wrap things up and go to a close. So question there from LM Marshall and again from Alon. Essentially, what was the name of the metrics and monitoring platform you used, Scott? And then follow on from Alon is which metrics do you use to monitor the models?
Yeah, sure. So we kind of hand rolled the metrics and monitoring platform. We used, sorry, my cat is attacking the box. We hand rolled the platform. We used MLflow as our model repository, and it helped with conjugate for metadata for our models. So basically, we would train our models and publish them to MLflow, and then we'd run the batch prediction against those models, and we would tag the models with names, which we then surface those names into our monitoring, which was just kind of time series like ClickHouse, Graphite metrics using Grafana dashboards on top of that. And we would basically we would, because we had some supervised models, it was easier, right? So we had that, if you remember the case working tool, that's actually generating labels we could use in real time as they investigate the cases against our score. So if they mark something as fraud or not fraud, we could surface that back, and we were basically tagging those labels against the score and using that to get like a precision recall F1 score and get histograms and that kind of stuff. So that was what we were monitoring for supervised. For some of the unsupervised models, it was a bit trickier. We basically kind of look at variance and what we're producing and just keep an eye on the range. We still haven't really figured out how to kind of alert on that yet, if you know what I mean. But yeah, we could alert on the supervised stuff because we could see drops in the score.
Perfect. Perfect. Thank you very much. I'm going to, as I say, draw things to a close with one final point. Obviously, as a business, as a team, you have lots of experience in terms of getting models into production. Is there such a thing as kind of one key takeaway or a couple of key problems that you see over and over again that you would perhaps kind of throw out there as your little, one thing to be aware of? Is that something that exists? Have you got any points in terms of what the main challenges are of getting a model into production?
I'm not sure. I don't think there's no silver bullet, I think.
Ah, damn it. What
Sorry.
a webinar it would have been.
But look to our playbook, which will give you a whole kind of a range of ways of kind of different ways you can put models into production and things to look out for. I mean, I will say some things that we find very helpful. So we like using things like a steel thread. So create that end-to-end thing early on, right? So you understand, because it's creating the model is one thing, but it's actually getting it in the hands of the users, the people who need to use it, and that's where you get your business value. And so that you understand the challenges around there. I'd say that's an important thing for me, at least.
Perfect. Perfect. Anything else to add from that, or has Simon done the job for the team? Has he nailed that question for you?
Pretty much nailed it. I've seen lots of challenges that could have been picked up a lot earlier when they were a lot simpler, because it wasn't sort of an MVP through. It was kind of built up and then tried to be pushed live. Definitely.
Perfect. Awesome. Well, I will draw things to a close there then. I think one thing that has become clear, Equal Experts are a very good partner, and really appreciate you taking the time. It was very, very clear by the volume of questions and actually the volume of comments in the chat that it's been a very well received session. So I'd definitely like to thank each of you individually for giving up your lunch hour in the UK and coming to share with us. And equally, I do say it quite often, but it takes a bit of time to prepare for these sessions as well. So you've not just rocked up and fired up the laptop and given a presentation. So I appreciate for the time in advance as well. And then very finally, it's been great learning more about Equal Experts. So yeah, definitely recommend all of you out there do go on to check them out. None of the guys specifically mentioned it, but I'm assuming they're hiring. Everybody is, so maybe go and check them out from that perspective as well and say hello. But yeah, thank you very much to you three, and thank you to everyone at home for joining us for our first session of 2022. Hopefully we see you at a lot more sessions going forward. But yeah, thank you all very much. Have a good one and goodbye all.
Thank you.
Bye-bye.